Welcome. This is probably your first video with me, Miss McSorley. Those of you that are my students watching this video. So I'm asking you to watch and take notes. So please get out that worksheet that you got in class. The homework assignment, I'm going to have you do that on Tuesday night for homework. And Monday night is just to watch and take notes. And study. Alright, because we got a quiz on Tuesday. Alright, so our objective, sorry, our objective is that students will be able to graph, evaluate, and write the equation of a piecewise function. Example number 1, evaluating piecewise functions. If we're given this function, f of x, and we're told two different pieces, where it says, well, on this part of the domain, when x is less than 2, then this is the part of the function that we look at. And on the part of the domain where x is greater than or equal to 2, we're going to look at this function. So we need to find f of 0, f of 2, and f of 4. F of 0. So 0, we're going to come up here, and this really says f of x. We're saying, okay, well, if x is 0, 0 is less than 2, 0 is greater than 2. Which of those is a true statement? Well, yeah, 0 is less than 2. Okay, so we're only looking at this one. One of the major problem that a lot of students have is they want to plug 0 into both of these x's, but that would not be the case. We're only going to plug in our value of x where it makes a true statement. 0 is less than 2 is a true statement. 0 is greater than or equal to 2, that's false. So we are not going to plug 0 in here. Okay, so 0 plus 2, plug it in, 0 plus 2 is 2. Oh, maybe I could be more clear. I think you guys got it. I was going to say, okay, we could put 0 plus 2 equals 2, right? We're plugging in 0 for x. All right, again, what about at 2? Notice there's a 2 on both of these, but only one of them is it equal. Here it's only values of x that are less than 2, but here it's equal to 2. So we plug in our value of 2. 2 is greater than or equal to 2. Plug it in. 2 times our value of x plus 1 is 5. 4 plus 1 is 5. All right, so f of 2 is 5. Let's do this one too. F of 0 is 2. And notice, with this function notation, we are given an ordered pair. When x is 0, y is 2. When x is 2, y is 5. So we're given a lot more information than just saying y equals 2. All right, so here we have f of 4. 4 is greater than or equal to 2. Plug it in. 8 plus 1 is 9. All right, so we're evaluating, and we're only putting it into the one that makes a true statement. So 4 is less than 2. That's not a true statement. 4 is not less than 2. That's false. So we wouldn't plug it in here. We'd only plug it into the second part of the piecewise function. All right. Write down any questions or confusions if this is confusing. We'll talk about it in class. All right. What about graphing? Now I'm going to ask that you make a table of values for each section of your piecewise function. Okay, so we're going to first focus on this first section. X's that are less than or equal to 0. We need to include 0 because that's where we're starting. Okay, so we start at 0 and we need x's that are less than or equal to 0. So less than 0 would be -1 and -2. I want at least 3 values. Technically I need 2, but it's good to have 3. Ooh, my pen doesn't want to work. Okay. I got a delay. I don't know what the deal is. Alright, here we go. So I'm going to write the function x plus 1. Okay, wait, whoa. Pause. Sorry, I'm not sure what I was writing. I was thinking about my y. Okay, so we got a y here. Y equals x plus 1. Now, this says g of x, but in my table, it's just a little simpler for me to think of x and y. So I'm going to have, in order to get my y values for these x's, I'm going to plug my x values into the x plus 1. So anything less than or equal to 0, I'm going to plug my x values into x plus 1. So I rewrote that there so that I can reference it. So I plug in my 0. 0 plus 1 is 1. -1 plus 1, 0. -2 plus 1, -1. All right. Now what this is going to look like, I see that when x equals 0, it has an equal sign, so it's going to be a solid filled in, oops, you can't see that, a solid filled in dot. And then it's all values that are less than, so -1, -2, and every value, so it's going to continue. Now I have this arrow pointing straight down, but this is the slope. This has a slope of 1 and a y-intercept of 1. This is just kind of letting you know what each part of the graph should look like. So let's go ahead and plot this. At 0, 1, when x is 0 and y is 1, I have a solid filled in dot. At -1, 0, it's part of my line. At -2, -1, again, it's part of my line. And my line continues forever. Okay, so for all values of x less than or equal to 0, we're going to be on that line, x plus 1, y equals x plus 1. Okay, now let's look at this one. This is saying, well, I'm going to use a different color for this part. -x is the function we're looking at, y equals -x, for x's that are greater than 0. Now this is one thing that's troubling to students, and we've talked about it in class a little bit. Oftentimes students want to start with 1, because they say, well, x is greater than 0, so it's not equal to 0. So they just want to use 1 and 2. But the problem with that is we don't know where we're starting from. What about at 0.0001? That's greater than 0. So we need a very, very, very close number to 0. And when I'm at 0, instead of it being a closed circle, because it's not equal to, we're just going to have an open circle. All right, and again, this is going to be an array that continues greater. Okay? So let's plug in our values. 0. Oh, you don't really have the opposite of 0. The opposite of 0 is 0. Opposite of -1, of 1 is -1, sorry, and the opposite of 2 is -2. All right, so let's go ahead and graph this. 0, 0, 0, 0 is an open circle. 1, -1, and 2, -2. Would be like that. All right, and that would be our piecewise function, g of x. G of x has 2 pieces. All right, I hope that was clear. Let's try another one. All right, I would like you to try to get this set up. I'm going to hit pause. I need you to hit pause. I want you to try to get your T-chart set up. Decide which values you want to use, and then once you've decided which values you're going to use, you're going to hit play again and see if we agree. Okay? We have to hit pause. You might think that I might not know. Ms. McSorley will never know that I didn't hit pause, but you need to hit pause because it'll give you some feedback. So hit pause, try it, and then check it. Did you get the same values as me? The most important thing is that you got the 2 in common, that they both have 2. Even though one is equal and one is not, they both need to have the 2. Here, we're going to have a solid filled in dot. Here, we're going to have an open dot. Even though we're not equal to 2, or we're not equal to 2 here, we're less than 2. So we're at 1.999999999, which is just so close to 2. We need to know where we're headed. Okay? All right, so let's go ahead and plug things in. Oh, wow, this one's simple. 2. There's no place to plug an x, so the answer is 5. No matter what x equals, y is 5. So it looks like we'll have an array because x's are less than 2. All of these are less than 2. And then here, greater than or equal to 2, so plug in 2. 2 times 2, let me use purple. 2 times 2 is 4, 6, and 8. And again, we're going to have array. All right, let's go ahead and plot these. 2, 4, 2, 4, solid filled in dot. 3, 6, 4, 8. So that's one piece, and the other piece is in blue. Oops. And we have 2, 5, and it's an open circle. 1, 5, and 0, 5, and it keeps going back. So that would be the graph of that one. All right, let's try the next one. All right, I'd like you to try this one all on your own. There's one extra piece here. you have a segment. So here's a ray, a segment, and then another ray. So this is a little different. I want you to try it, set it up, see if you can do it, because I know you can. Oh my gosh, you guys are so smart. All right, so hit pause, and then hit play, and it'll pop up. I just want you to see an in-between phase, double check, see if you agree. Here we're starting at -3, even though it's not equal, right, because we're going to have an open circle. Here, -3 to 1, so I chose those as my endpoints, and 1 in between for accuracy, and then greater than or equal to 1, so values greater than 1. And I'm using 3 different colors just to help you guys in the beginning till you see it clearly. All right, go ahead and hit pause again, try and graph it on your own, and see if we agree. I hope you're using pencil. Your graph should look like this. Notice this was the first time that our two functions, ooh, is it gonna let me? Nope, they're connected, sorry. This was the first time that our one function had an open hole and the other had a filled in section, and they ended up meeting at the same point, and that's okay. It just happens like that sometimes. But notice this, we call these piecewise functions. They are functions. So notice it passes the vertical line test. There's only one of them is equal to that point. Over here, this one's not equal, this one is equal. If these were both equal, it would no longer be a function because it would fail the vertical line test. So we want to be careful. It's one way to check our work is to see, all right, as I do the vertical line test, is there ever a place that I have two pieces of my function on the same part of the domain? Okay, and here's another way of kind of looking at it. So the domain is separated into these three sections. All x's that are greater than 1, all x's between -3 and 1, and then all x is less than -3. So less than -3 this way, between -3 and 1 in the middle, and then x is greater than or equal to 1. All right, I hope that was helpful. So with that information, I think you guys will be very capable of graphing some piecewise functions. Now here are a couple where we're writing. So we're given the function and we need to write the equation. So you can choose any f of x, g of x, h of x. The letter here doesn't really matter. But in this, I'm going to have two levels. And I'm going to kind of get this ready. I know that I'm going to need the function, like y equals mx plus b. So far, these are all linear functions. In pre-calc, you're going to do, you'll have all sorts of kinds of functions. But we're going to pretty much stick with linear functions for now. So we're going to have something, this is our y equals, so we don't need to put y equals mx plus b, because this is our y equals. So all we need here is the mx plus b section of our equation. And then this is going to be our domain restriction. We're only restricting the domain, we don't restrict the range. So, oh, let me write this, restriction. So we're going to say x's that are greater than something, x's that are less than something, or x's that are between something and something else. Okay? So let's go ahead and start. I like to start with my domain, but you may start wherever you feel comfortable. So I look at this and I say, okay, here's my x-axis. I'm starting here. One function is x is less than -1. And this function is greater than or equal to -1. So I'm going to start by identifying those parts of the domain. So here we have our function on x values that are less than -1. Less than -1. All of these, sorry, are less than -1. All of these x's over here for this function are x's that are greater than or equal to -1. Notice they're both not equal. One is equal, one's open, one's closed. Okay? I need to erase this because it's just going to get in the way of finding the accurate equation. Okay. So, now we want to write the equation. And you guys have become really good at this, and we have our quiz on it tomorrow, so this is actually really good review. Um, in order to write the equation of this line, we can do all sorts of methods. We could find the slope, say, okay, rise 3, run 2, so 3/2 is our slope, and then we could plug in a point, like, let's see, negative 3, 0. Negative 3, 0 would be a point on that graph. We could continue rise 3, run 2, and see, okay, well, where would I cross the axis? It looks like it would be halfway up, so it's 1.5. So let's see, 1, 2, 3, 4.5, which would be 9/2. Okay, but let's just kind of go over it. So if this is x and this is y, we could plug in, right, to our y equals mx plus b. We're going to plug in our y value, 0, our slope, and our x value, plus b. So here we get negative 9/2, and then we can add 9/2 to both sides. And I'm going to encourage you not to write it as 4.5, but to encourage 9/2, because, and again, it's not called an improper fraction anymore, it's called a fraction greater than 1. Alright, we're changing things. So, the equation, we just decided that our slope is 3/2 and our y-intercept is 9/2. So we already have our y equals 3/2 x plus 9/2. So that's the equation on this part of the domain. And I want to make sure, okay, this is the graph I'm looking at on that part of the domain. We're good. It's an open circle. It's not equal to. And then this one, oh my goodness, this one's pretty simple. Because it's just one value, the equation of this is y equals negative 2. So here, I already have my y equals negative 2. That's it. We are done. So this is writing the equation, the piecewise function, that describes that graph. Alright, I'd like you guys to get your f of x set up, or g of x, let's call this one g of x, doesn't matter really. I want you to get it set up and do as much as you can and then double check. Now, I do want to note there's a little dot right here and that it was an error, so please ignore that little dot right there. I'll try and kind of fix it so it looks more accurate. Okay. So we don't have a dot there, it is a function. Alright, so I'm going to hit pause, you hit pause, we'll do it, and then we'll check our work. Alright, hit pause. So far I've just done my domain restrictions. I said, alright, between negative 10 and 3, we're going to have one function. Oh, I can do that one really quickly. 1, 2, 3, 4, 5. Alright, so my function is y equals 5 on the domain from negative 10 to 3x is greater than negative 10 and less than or equal to negative 3. My other function is on x values that are greater than negative 3. Only on x is greater than negative 3, I'm going to have this function. And I can find the slope, negative 2/5. And then I need to find my y-intercept. And again, it's not a whole number, so we want to be careful. Alright, you find it, I'll find it, we'll check and see if we got the same thing. Ready, hit pause. What I got for my y-intercept is 34/5, which would be 6 4/5. So let's double check, make sure that makes sense. 1, 2, 3, 4, 5, 6 4/5. Okay, I can buy that. So we're going to say we're adding 34/5. Alright, and that would be the piecewise function that describes that graph. Alright, you got one more. I want you to try it on your own. And then check it. So hit pause, try it, check it, and you're off. Alright, and this is what I get for this section. I'm assuming that's filled in. It's a little hard for me to see. If it's not filled in, I apologize. There will be a slight difference over here, right? We wouldn't have that equal to. But that's what I got. So I want you to make a note, see if you had any confusions. Write down your questions so we can go over it in class. I appreciate you watching the first of maybe many videos. We'll see how you guys like these. And it'll help us to do some more fun stuff in class. So homework number 7 I'm actually going to assign that Tuesday after the quiz, but if you want to get a head start on it, you can. I also want you studying for that quiz that's tomorrow though. Alright, thank you for watching. I'll see you tomorrow.